So, two-way tables. Let's have a look at this question just here. So we want to take this information and we want to just pop it into this two-way table. Right? Two-way table is just a nice way of representing information. So there are 170 students in year 7 at a school. So that means we can put 170 just there. All of these students, they either walk to school, they get the bus, or they cycle. So 82 of the students are boys. So we can write 82 in there. So we're just going to put in whatever information we can. 33 of the students get the bus to school. 33 get the bus. Doesn't say anything about boys and girls just there. And then 19 of the 41 students that walk to school are boys. So that's telling us, about the ones who walk. It tells us 19 of the 41 students who walk. So you're just going to read it carefully. And then 19 of those 41 are boys. There we are. 56 girls cycle to school. So 56 girls cycle. Sometimes it's a good idea to just tick things off as you've done them. So we've got the 82, okay, yeah, the 33, we've got the 19. Each number will go in there somewhere. Right, so we know that we've got 170 students altogether, 82 are boys. If you want to use your calculator, it's fine. 170, take away 82, there we go, look, 88. We can just fill out the other numbers now. This number here, so 74, if I add those guys together there, 74, add something is 170, okay? Easy way of doing that is just to do 170, take away 74, right? 96, there we go. So 96 students cycle to school, 56 are girls, so therefore 40, okay? 40 boys cycle. I've got 19 boys walk, 41 altogether, so therefore that number in there has to be 22. 41 take away 19 is 22. Now I can work going across to get these over here. So 19 and 40, that's 59. So 82 take away 59, so 82 take away 59 equal to 23, and therefore that other number has to be 10, looking at it that way. Just a quick check, going back this way, 30, 80, 88, yep, it all seems to work. Alright, now how these questions might get slightly trickier is it might ask you a probability question or a percentage question based on this just here. Okay, I'm not going to get into probability on this, but that's how the question could get slightly harder, or it might refer to like a ratio of boys, girls. Again, that's just getting a bit more complicated. Right, I'm not going to worry about that for the moment. Right, I'm just going to show you one more question quickly. The difficulty with this question is, well, we've got an advantage because I'm telling you that this is two-way tables. It's seeing this in an exam and thinking to yourself, I've got to draw a two-way table. That's the hardest bit. Actually, if you just start off and think, right, okay, how can I go and draw this information? How could I represent this information in a better way? Then the question is relatively straightforward. It's just making that connection of seeing this and thinking two-way table. So we've got maths. Each student went to maths, English and science. Okay, so it doesn't matter. I could do maths, English, science down the side. I'm going to do it going across. So maths, English, and we got science, and then we can have a total. What else have we got? We're told it's about Saturday. It's 100 students attended a revision lesson at the weekend. So it's talking about Saturday and Sunday. So therefore, let's write in over here. So we can put Saturday, and we can put Sunday, and we got total. Okay, so let's just quickly draw a table in. And that's probably the hardest bit of the question, is recognizing that a two-way table will make your life so much easier to do. Here we go. I'll just finish these lines here. Now you can do this question without doing a two-way table. It doesn't, like I say, it doesn't say draw a two-way table. It is possible to work this out without drawing a two-way table, but you can see here it's just easier. All right, I want an easy life. 100 students attended a revision lesson at the weekend, so therefore we know that that's 100. Each student went to maths, English or science. So we'll go on to that. So we know that these three numbers here will add up to 100. Right, 55 of these students attended on Saturday. So 55. So that's obviously got to be 45. Over the weekend, a total of 40 students went to maths. So that's that number. 12 of the 27 students that went to science went on Sunday. Okay? So 27 went to science in total, and 12 of them went on the Sunday. So we've got that information, we got that information, we got that, we got that. Sometimes it's easy to miss something. And 10 students went to English on Saturday. So 10 went to English on Saturday. Right, we should be able to fit it all in now. We got, that must be 15. I've got that from the 27. We've got, that's 25. So therefore that's got to be 30. So it's 40, 50, 55. So that's got to be 10. 30 and 10 is 40. Coming back this way, that's 22. So 22, add 23. Add the English up, and we've got 33. Just have a quick double check to make sure this comes to 100, 50, 60, 100. Yep, I'm happy with that. Don't forget to actually answer the question, how many students went to the maths revision lesson on Saturday? If you notice, I didn't even look at that until I've got to this stage. How many students went to maths revision lesson on Saturday? So maths revision on Saturday, so the answer is 30. Alright, so you're going to have a go at doing a few questions, and hopefully you'll get on okay with these. Remember, the hardest bit about this question here is just knowing to draw a two-way table, because it doesn't say draw a two-way table. If you recognise that, you look at that and you think, two-way table would be useful, that's the hardest bit of the question. Alright, so let's have a go at trying to do some.